Let's get into the big topic of open source, something that we actually say at Red Hat.
This is so awesome.
We are an open culture that believes
actually
in
a big
importance
piece
of
of
It's that process that a developer, or let's say,
as the Kubernetes ecosystem really boomed.
Hello, good morning, good evening, good afternoon, wherever you are in the world. I'm Johnny Rickard. This is the Ask an OpenShift Expert live stream. You may notice that my co-host Andrew Sullivan is not here. He is out saving the world again, as usual. Actually getting ready for Red Hat 1, which is next week. So like Andrew being the most important person in the room half the time, he's super busy getting ready for that, attending a lot of mandatory meetings and stuff. So let's pray for Andrew, make sure he makes it out of these meetings alive and can actually get back to doing real work when Red Hat 1's over. With that said, today we've got a pretty interesting topic. It's something that we've been trying to plan and get coordinated for a while now. I think since like October, November. It's cool that it's finally happening. CMAC actually hit us up and let us know that there's a feature coming out, or I don't know if it's a feature or a product. I don't know how the right way of saying it, but there's this new awesome thing that's come out and it's available now. And so we've got Steve and Nikola here to talk about it. So do you guys want to do a quick rundown of what we're going to talk about?
Sure. So again, I'm Steve. I'm the product manager with the GitHub Actions team. And we're actually here today to talk to you about running GitHub Actions on OpenShift using Actions Runner controller, also known as Arc. And with me today, we have Nikola Jokic, who is a senior software engineer on the Actions team. And he's the primary person that works on Arc as well.
Nice. Awesome. Thank you. All right. So before we get started, I don't have a lot of top of mind topics. Obviously, we have the schedule coming up. Next week is Red Hat 1, so we're not going to stream next week. If you're not familiar with Red Hat 1, it's a huge internal, I guess it's not completely internal, but it's internal with partners and stuff like that. It's a big tech convention that we go to where all of our consultants and sales teams and some just different folks around Red Hat and again with our partners get together, and it's a week of enablement and social networking and just building your network and getting smarter on the technology that's out there and the stuff that's kind of on the horizon. The week after we have we're gonna have Ben Schmaus come on and he's gonna talk about NVIDIA's GPU Direct RDMA, and then we're gonna have sorry, I'm going off memory here. We're gonna have the Trusted Artifact Signer team come on and they're gonna talk about the Taz product that's come out. It's been out for a while, but they're actually gonna come out and they're gonna talk about it and do a demo. And then we've got Peter Kreuzer coming back to do some more CNV user experience. And then we have the dude's name is, I can see his face now, but I can't remember his name. Anyways, he's going to talk about confidential containers out in the field. So he's been working with confidential containers for some time now. And he's going to come out and he's going to talk about all the things that he's kind of seen, like the good, the bad, and the ugly of confidential containers. So got a pretty full schedule coming up, which is awesome. And again, we're out next week, but once we get back in the swing of this, we'll actually be hopefully back on track to do a stream every week again. So happy New Year, happy holidays. Hope that everybody had a good break. This is our first stream coming back. So I'm a little excited. I'm going to try and slow myself down here so that way I don't just run through everything. But cool. So Steve, I'll kick it over to you. How about let's get started.
Awesome. So let me share my screen. All right. Are you able to see it?
Let's see here. So I just added it. There we go. Here we go.
Perfect. All right. So we already did introductions, so we can skip through this one. Give me one sec. Awesome. All right. So as we said earlier before, we are going to talk about running GitHub Actions on OpenShift using Actions Runner controller. For the agenda today, we're going to first talk about how GitHub Actions, Arc, and OpenShift work together, how this whole collaboration between GitHub and Red Hat started, how Arc runs on OpenShift, high-level installation guidance, a demo, and Q&A. Then we also added a bonus slide yesterday for common operational pitfalls and experiences that people have had when doing this setup. So to start, I assume many of you who are attending are familiar with OpenShift, but some might not be as familiar with GitHub Actions. So GitHub Actions is GitHub's built-in automation platform for CI and CD as well. Developers define workflows alongside their code, and those workflows are executed by actions runners. GitHub provides hosted runners, which work well for many teams and are supported by the Linux, Windows, and macOS platforms. We also have standard runners, which are free for open source repositories in the public. And then we have larger runners, which are mainly used by enterprises and bigger organizations for heavier workloads. These allow larger machine sizes, and you can even have custom runner images that allow you to preload tools and dependencies on that virtual machine image. And then for customers who use Azure, we offer Azure Private Networking with VNet injection, which allows runners to securely access internal resources without exposing services publicly. For many organizations, GitHub hosted runners provide a powerful, low operational overhead experience. However, not every organization can rely solely on GitHub hosted infrastructure. This is mainly because regulatory requirements, data residency rules, network isolation, or on-prem dependencies often mean that CI workloads must run inside the organization's own environment. And that's where self-hosted runners come in, and that's where Actions Runner controller fits as well. Arc is a Kubernetes controller that dynamically creates short-lived ephemeral runner pods in response to a request for a GitHub Actions job. Runners are created on demand for each job and automatically cleaned up when the job completes. Running Arc on OpenShift allows organizations to keep GitHub Actions close to their application's infrastructure while aligning with OpenShift's security model and operational practices. Arc sort of becomes the bridge that connects GitHub Actions to OpenShift. All right. So how did this thing get started? Well, in early 2025, the Red Hat team and GitHub sort of came together around a clear customer need. Our customers wanted to use GitHub Actions, and they wanted to run it on OpenShift. Many enterprises, government entities were already using OpenShift as their platform, but they needed GitHub Actions to support running workflows on OpenShift. And it actually got to the point where we had so many support tickets and requests that at a point in time we had to put in our documentation that we did not support OpenShift. Well, that changed quickly.
Wow.
The team, reached out and had actually published guidance on how to securely deploy Actions Runner Controller on OpenShift, showing people how Arc fits within their security model. And so by summer of 2025, GitHub shipped a public preview for OpenShift with Actions Runner Controller release 12.0. We took that time to collect feedback, continued collaborating with the Red Hat team, and then shipped OpenShift support under general availability in October of 2025. So it took about a year, but we got things done.
Awesome.
All right. So next we'll talk about essentially how Arc runs on OpenShift. Arc connects GitHub Actions to OpenShift by essentially turning jobs into Kubernetes pods. The controller manages Arc resources. The listener communicates with GitHub Action Service to receive work, and runners are created dynamically as ephemeral pods that only exist for the duration of a given job. A key design principle here is namespace separation. Our components run in one namespace while runners execute in dedicated runner namespaces. Each component has its own permissions. The controller needs cluster level visibility, the listener only needs scaling insights, and the runner pods are locked down to the minimal access required to execute jobs. On OpenShift, security context constraints, or SCCs, are critical. Runner images often require specific UID and GID values, so a custom SCC bound to the runner service account, so that it is bound to the runner service account, which avoids privileged access. The lifecycle is relatively simple at the end of the day. A workflow triggers, a runner pod is created, the job runs, and logs and artifacts go back to GitHub, and the pod is then destroyed. Very, very fun thing to set up. All right, so we'll go to the next slide. All right, so next is sort of a high-level installation guide for Arc on OpenShift, and for this one, I'm going to pass it to Nikola to sort of walk you through this experience. Nikola?
Yeah, so I can start by explaining each of these points one by one. So to understand the ARC's architecture, you need to basically have to separate two basic charts. One is related to the controller and one is related to the actual installation of the scale set. The controller should outlive every scale set. You can think about it as basically something that would ideally run forever. While scale sets can be installed or basically removed when necessary. So when we install the controller, it has some permissions on the cluster level, but in order to reduce the amount of permissions that we allow, we don't have secret access to the entire cluster. As soon as you start installing the scale set, we would apply specific role binding to the controller so it can see secret inside the runner's namespace. Therefore, you can basically, the controller has visibility over a scoped namespaces where you have installations on. So these things are being differently handled in OpenShift just for a bit. So security context constraints, as Steve pointed out, you have to explicitly allow certain fields or certain capabilities on the container so it can run properly. This is especially important once you start running Docker in Docker. Then you have to have privilege escalation, at least for the Docker in Docker pod. Now, the interesting thing about this architecture for auto-scaling runner set is that the runner is basically fully controlled by you. By default, the spec of the scale set can be expanded by specifying the mode of Docker in Docker, for example, but you don't have to use that. You can fully control every part of the spec related to the runner and apply security context constraints based on your constraints. Well, so when you deploy these things, so when you deploy auto-scaling runner set, there you should be able to see, and we will see that in the demo, you should be able to see a listener app being created. The listener is basically the brain behind scaling. So the listener will start asking GitHub service about what jobs do we have? Do we have to scale up or down? Is there a job that is being done? And based on that, it will patch the ephemeral runner set resource, which is an internal resource of the controller. Then the controller will pick that up and then start deciding which pod should it scale down or should it scale down or up at all. And then we get to the interesting parts, which is testing the setup. So when you set it up, we will show you how it should normally look like. But when you set it up, you should first see the controller. You can see the logs of the controller. And once you install, the listener should be provisioned right away in the controller's namespace. And then after that, if you specify min runners, you should also see the runner being spun up and waiting for jobs.
So do you have to have any like specific, I'm assuming you have to set up like a GitHub auth token or whatever, right? Some kind of like, some kind of application or whatever within GitHub for the runner to associate with, right? Like you assign a token to it. So then that way when you register in OpenShift, it can communicate and it knows like, hey, I'm authorized to talk to GitHub, and GitHub knows that it's authorized to talk to that OpenShift cluster. Is that about right?
Well, for this token, you are basically using it for authorization between a GitHub service. So in your values.yaml file for the scale set, you specify the scope where the scale set will be installed on. So it can be on the org level, it can be on the repo level, and then you specify the personal access token or GitHub app, preferably,
Okay.
in order to authenticate to the GitHub service. And then from that point on, basically the listener will get that configuration and know which scale set it. So the controller will actually create the scale set, start the listener opens up the session, and then starts talking to the GitHub service.
Okay. So why do you prefer the GitHub app over the personal access token?
Steve, I think this one's for you.
Yeah. So PATs are very pervasive, right? And people will add overscoped PATs, right? Giving them admin permissions, etc. If someone leaves, that PAT's gone, right? CI is broken. And so we really want to push people towards GitHub apps that have fine-grained permissions that are scoped to the functionality that you need to execute. So for example, you can scope a GitHub app for running actions jobs and viewing like repo contents exclusively. And then that app isn't reliant on a given individual. So they're very good for building automations and running things like actions as opposed to a personal access token.
Okay, awesome.
And they're a bit more secure.
Yeah. So when you said that, I was trying to think of why initially. Then I was just going through it in my mind. I'm like, yeah, because I do like all or whatever it is. Like, yeah, it's like the whole world. Yeah. All right. Cool.
Yeah. Cool. All right. Thank you for running through that, Nikola. All right. So given that we have been operating Actions Runner Controller for a while, I've had OpenShift support for nearly a year at this point. We wanted to share some, some operational lessons learned with everyone and some common gotchas essentially that we experienced. So one of the biggest failure modes is configuration. So security context constraints, issues that prevent runner pods from starting, UID, GID mismatches between the runner image and OpenShift security restrictions, and RBAC gaps where the controller can't patch into the namespace. So where to look? This observability guidance applies to running Arc generally, on any platform, but especially with OpenShift. So when jobs don't start at all, look at the listener first. It's the component that receives the job available message from GitHub and triggers scaling. If jobs start but fall partway, look directly at the runner pod logs. Since runner pods disappear and they're ephemeral after each job, log retention for the controller, listener, and runners are essential. We provide metrics, and the metrics from the controller and listener, plus we provide Grafana dashboards, are very useful in sort of making sure that you can kind of backtrack and analyze what's going on when you do run into issues. Arc also requires you to think about scaling, depending on the size of an organization, how many developers you have, how big your clusters are. CI can burst hard, right? Especially during peak times during a given day when everyone's pushing a lot of builds. So you need to plan node pools for spikes. And one thing we do recommend is creating separate runner scale sets for different workload profiles. This will come with the Actions Runner Controller 14.0 release and is also on the public roadmap. But we are bringing back multi-label support for Arc. So if you have a scale set that can run multiple build types, you can assign it multiple labels so that a job can be assigned to different skill sets and help pick up jobs from different ones. Whereas today, you have to be very discrete in the workflow file and stating that I want it to run on this scale set, and that's the only scale set that the job will be picked up on. With us bringing back multi-label and release 14.0, it kind of expands the use case for having a scale set be used for multiple types of jobs. So that's just something that's
Sorry about that. Sorry. Can you kind of jump into what skill sets are? Because it's like just listening, it sounds like a skill set is it one skill set per type of runner that I want to use? Is that am I thinking about that the right way? Like what is a skill set like in this context?
That's a good way to look at it. Look at a skill set as like a unit of compute that can run a job, right? And when we talk about creating different profiles, you may have a GPU skill set. You may have a skill set that has additional storage because it requires more disk space to run. You may have some that require more RAM. So if you have different compute that you've tailored for different types of builds and applications, then we would recommend creating a scale set per type of build if they're special use cases. And there are a lot of customers who just create general purpose scale sets that can run on like any build, right? So if you're running like issue ops or something like that, you don't need it to run on the GPU scale set, right? And that's when like the general purpose like cheaper machines can be used. So just all this to say, setting up one scale set is we'll get the job done, but it may slow you down, and you might create some bottlenecks. So that's why we recommend creating scale sets tailored to certain types of builds.
Okay, gotcha. And then when you define a skill set, and pardon my ignorance here, but so when you define a skill set, can you set it up to where it'll create a PVC so that way you can share it between runs, like the content, like I'm just thinking in OpenShift pipelines world where you'd spin up a PVC, and if I want to reuse that between jobs or tasks or whatever, I've got that data there. Is it possible to do it with this or no?
Nikola has been working very hard on this for
the
entire calendar year. So
my man,
I'll let you. Yeah. This was a big one. I think this was release 13.0. Nikola, were we introduced?
Yeah. And just so you know, the runner spec, as mentioned, is completely controlled by you. So basically, you can think about the runner as just a pod, and you can specify whatever volumes you want. You can specify whichever environment variables you'd like. There are just very few assumptions that we have to take from the controller's perspective, and that is that the name of the runner pod or the runner container is named runner.
Mm-hmm.
And even for the entry point, you can customize that and move it away. But we are expecting that the exit code of the entry point signals the state of the runner, if it is being killed or it's exiting successfully, regardless of the job status. But as far as the volumes and sharing between multiple runners, for example, everything is controlled by you.
Okay, got it. And then CMAC, this might be a question for you. And I'm sorry I didn't introduce CMAC. CMAC, you're technical marketing. I'm not sure what you're technical marketing or product marketing. I can't remember exactly for sure. But you do OpenShift pipelines, and you're like the head honcho over the pipelines in Argo and all that, right?
Right. Yeah, I'm part of product management team at Red Hat for hybrid platforms. My focus is the cloud native bits that run on OpenShift, like CI/CD. You mentioned pipelines, which is the downstream of the Tekton pipeline project, and Argo CD, Istio, Knative, and our cloud native stack for building applications, essentially.
Awesome. Yeah. So the question that I had is do we have any are there any Red Hat builds? Or Red Hat images that we would use for the runner? Do we have a Red Hat UBI runner image that we're putting out, or is it just we're taking it directly from GitHub?
We're not building any. Yeah, go ahead, Steve. Yeah.
No, so it's just a GitHub Runner image. It is a very minimal image, right?
Okay, gotcha.
So other tools and dependencies still need to be installed and customized for your needs. However, I will say that we have ever-growing customer requests for GitHub create a more opinionated image, install more tooling, etc. Especially in the day of agents. So at GitHub Universe this past year, we announced self-hosted support for Copilot coding agent, right? Which means that if you're running on Actions Runner controller, rather than assigning it to a hosted runner, as I mentioned earlier, you can update your Copilot configuration settings to then run on self-hosted, and that being an Arc cluster. It could be, the machine on your desktop, as long as it's running on Linux. It doesn't run on Mac or Mac yet. But we've had many customers ask for that sort of thing, and so it's been an interesting journey seeing the evolution of self-hosted and the multiple things that it can support.
Okay, awesome. Thank you. All right, I'm done. I'll keep coming up with questions.
Those are really good questions.
I can ask a follow-up related to what Steve mentioned. Steve, could you expand on that a little bit? So if a customer wants to install their dependencies or add tools that they use to the runner images that GitHub ships, how does that look like? It's just Docker file from the GitHub images and do their own thing, or something else that they need to be doing?
Yep, they just configure it from there and customize it when they deploy it. Now that being said, I will go back to the point of we will start looking into what it means to have more opinionated images for self-hosted. That means getting additional engineering support from other teams, especially in the day. Go back into the day of agents, where other people are looking for other tooling to be installed natively, and so we're in that research process, identifying what that is, and even looking at images generally speaking, to improve that experience, especially with our recent release of custom VM images for some of our runners.
Awesome.
Cool. Well, next is actually the fun part. So I will stop sharing. And Nikola is going to do a quick demo of running Arc on OpenShift. So where's the stop sharing button? There it is.
All right, here we go.
Yeah, so today I took some time to set up local OpenShift cluster. So using CRC, I was spinning up basically something that would be similar to running the actual OpenShift. And I have to call out this amazing article published by Red Hat. So basically, you can just follow along and see how exactly you can basically set up Actions Runner controller on OpenShift. As we mentioned before, you need to provide some configurations related to security context constraints, and you need to later apply some policies. But other than that, the installing skill set is basically just applying a Helm chart to your cluster. So just so you can see, basically these were the only things that I used to set it up. I have security context constraints, and I have a cluster role, then applied the policy when I needed, and everything was set up correctly. In this nice K9s view, you can see that we have Arc systems, which is usually what we use in documentation when we install the controller, and where the listener will be. And we have a single runner, and that's going back to what I said, setting up min runners. It's going to spin up a single runner waiting for jobs to come in. You don't, of course, need to do that, but if your cluster is busy, it can speed up spinning up the runner, so you can pick up job as soon as it is available. There are a few things to mention here. So the controller log, just by going L here, you can see all the states that we are going through when we are reconciling on every auto-scaling runner set. So there are a few internal resources that we compare. And if there is a bug, something like, for example, pod is not spinning up, you can check it here to see in what state is it in. And that is quite important for debugging, especially when submitting an issue. The other log that is quite important is the listener log. And this is going back to what we were previously talking about, listener asking for jobs and figuring out how many runner pods should be spun up. And the runner log is basically just the basic log of the runner. It looks exactly the same when you spin it up. Locally, it's not writing to a file, it's writing to the standard output. And as soon as this is done, and you can see every single one of these components, you can go to spin up a job. I just have a basic CI job that is a matrix job, and we'll see how it looks like in K9s, how the pods are being spun up.
So we did get a question. The question is, would you recommend running Arc on its own dedicated cluster, or would you have it running on dedicated nodes in a shared cluster?
Definitely on the dedicated cluster, because having a shared cluster can have different policies, and sometimes your jobs do need some permissions that you wouldn't ideally want to apply on the shared cluster. So keeping them separate is always a better way to go, to be honest.
Okay.
And just to return here back just for a quick second, you can see these runners are being created. They started running a job. This UI is a bit stale, but these jobs are being done. And the runners are slowly going down. You can potentially sometimes see this where the runner stays, and that is basically intentional. When you have a spike of jobs, this one this one runner that was created during scaling up and scaling down will quickly pick up the job. But as soon as the cluster becomes idle, we are going back to the min runners, as you will be able to see in less than 40 seconds.
Okay. And your workflow is,
And min runners,
sorry, go ahead, Steve.
I say, and min and max runners is something that you configure yourself. So if you wanted to have 100 machines being idle at all times, that's completely within your control.
And this is going down. So basically, when your cluster becomes idle, there is a period of around 50 seconds of no messages. Then we will issue a request to the controller saying, hey, make sure that this state is where it needs to be. And this is only happening when your cluster becomes idle. So usually, like, the pattern of jobs would be some jobs are coming in, others... the jobs are usually flowing in, is all I'm trying to say. And this feature of not actually deleting the runner makes it faster to react on things. And it's usually up to 1 or 2 runners being spun up when the cluster becomes idle.
Okay. And as part of your CI, it's in your workflow that says that determines like when this job gets run, right? So it's like it's either on commit or like on PR or whatever, right?
Yeah. So
Okay.
here you can see what Steve was talking about. I'm specifying runs on as the name of my scale set. This can be changed as soon as we add multiple labels, but you are very specific, specifying which scale set should run this exact job. And of course, all the triggers you can have on like pull request or something else. I just use dispatch so I can control everything that's happening.
So
Yeah, we have a series of events. Yeah, okay, nice. You put it in
Yeah.
the chat. Yeah, a whole bunch of different events run workflow triggers. I mean, you can even kick off a workflow and actions based off of an issue comment.
Oh, that's cool.
Yeah, and maybe the last thing just to basically show here, although this is quite verbose, is in these states in the log, you can see basically these messages coming in. So you can see the target number of pods based on the messages or job completed message. So even with that, you can maybe inspect the log or just use the metrics published by the listener. So you can basically what you can do is optimize your overall CI system.
And so when this kicks off, it's kicking off a job, and then that job's kicking off a pod. So like I'm assuming when it deletes, is it deleting all of those artifacts? So it's obviously you have your like your idle number, right? And then so like when it's rolling those other things out, right? So say if you're going from 4 back to 1, does it actually delete the pod and the job itself, so it like completely cleans house, or is that something that like as a maintenance task you have to go in and do and like prune those out?
Oh yeah, so first, it's not the job, it's the ephemeral runner controller that is basically doing similar to what the job controller is doing, just having a bit more control. But the overall idea is definitely correct. So when we are scaling up, what we are doing is creating the pods. But as soon as the runner finishes, it's going to exit with exit code 0. And then the controller will pick it up, remove the configuration which is stored usually in a secret, and then that pod goes down. And whenever we calculate the number of ephemeral runners running, it will automatically scale down.
Okay.
If you know what I mean. So it
yeah.
exits and we just don't restart it.
Okay. So like if I were to do like kubectl git pods in that namespace, I would see them all gone, right? Or I would see the one either running and then the others completed for a certain amount of time. And I guess that's what I'm asking is like, does it prune the ones that are completed or that have completely exited?
Yeah, it automatically deletes them. There is one particular situation that is interesting, which is when controller doesn't think it can recover the actual runner, it will put it in a failed state, which is going to be counted in the scaling. So keeping the failed state has basically two purposes. One is so you can inspect it manually and make sure that like you understand what caused that. And the second one is if there is something wrong with the spec or the cluster, we don't overscale and then fill up the whole etcd depending on the problem, fill up with pods that are going to be useless. So we just make sure that that doesn't happen with that mechanism.
Awesome. Yeah, I think that's ultimately where I was going, right? Because if you have a bunch of pods that are completed, and then now they're, even though they're dead, they're still taking up resources, so they're ultimately trying to get to that point. We had a question from Sudo Tamil. Oh, I'm sorry, go ahead. I'm sorry.
Yeah, I just wanted to make sure that like everyone understands this. Whenever the runner exits, it's going to stop the pod, and then we are going to clean up resources right after that. Sorry for jumping in.
No, that's perfect. That's yeah, exactly. All right, so Sudo Tamil, I'm sorry if I butchered your handle. In a multi-tenant OpenShift environment, how does Arc handle dynamic autoscaling of self-hosted runners when multiple namespaces trigger parallel GitHub Actions workflows? That's a lot.
To be honest, we are not running in a multi-cluster environment. There can be some changes made so we can run it in the multi-cluster environments. But going back to your previous point, when someone asks, should we run in a shared cluster or run in a dedicated cluster, you usually want to make sure that like one cluster is optimized for your workload, maybe on the specific set of skill sets there.
And Nikola, correct me if I'm wrong, but I'm just thinking of some issues and triage and so forth with customers essentially running 40,000 jobs within 1 hour. Is that having other applications installed on the same clusters can sometimes delay messages and impact jobs being assigned if there's like more activity like than anticipated. We've even seen things where issues where additional tooling on the cluster has caused this issue. So for now, as Nikola said, we recommend that everything being on a single cluster for Arc. And if you have other clusters, that you keep those separate from what you're doing in your CI.
Interesting. It makes sense though, right? Like the cluster gets overloaded and then it can't report. Yeah, that makes sense.
I mean, there's so many messages firing. I mean, you're talking about 40,000 jobs in 1 hour. You built for purpose.
So is there a lot of chatter? Just relatively speaking, with Arc, like the runner and the controller, or between GitHub and the controller? Or is it just like there's a notification, hey, I've got stuff that needs to change, and then there's like just that normal interaction, like, hey, go run this job. Here's the sync set, do your thing. Or is there like a bunch of like back and forth logging that's going on, or chatter that's going on?
Yeah, so basically for most things, the controller installs the watcher that gets notified on every event that maybe pod or something else is going through. So whenever you have a huge spike like that, there's of course going to be a lot of create requests which are going directly to the API. And then after each state being changed, usually through the watch mechanism, we get notified about the change being the change. And then we try to figure out, okay, we are now in this state, we need to do the next thing. So for each job, we will spin up the secret, we will spin up the pod, and then after pod gets into the running state, we patch the other resources, and there's a lot of things going on in between. And that's why running a lot of applications on the cluster, especially if they are doing something that is quite internal to Kubernetes itself, it can delay getting these jobs, these messages from the Kube API, which makes it slower.
Okay, gotcha. And so Sudo Tamil had one more question. It was, does Arc rely purely on Kita/HPA for scaling, or is there some other internal magic that you guys are doing?
It definitely doesn't rely on like you have historically you had a community version of Arc and you have our supported version of Arc. So we don't rely on HPA at all. There is a controller which is called ephemeral runner controller, which does the scaling, and there is another controller which is ephemeral runner set controller, which is basically creating ephemeral runners. So we are not relying on almost any internal resource of the Kubernetes itself. The listener patches the ephemeral runner set. The ephemeral runner set creates ephemeral runners, and the ephemeral runner controller makes sure that everything is in a correct state and can run the actual job. After it's being done, it deletes itself. So the ephemeral runner set controller makes sure that the scale matches the desired one.
Nice. And you don't have to, like, you can use obviously GitHub.com, or you can use like GitHub Enterprise or whatever, right? Like there's potato, you're going to have this capability exists between both platforms. Okay.
Yes, and also GitHub with data residency is the.
Oh, what's that? I'm sorry. What's
Yeah, so it's it's a new. So it's actually GitHub where you're at. So for customers who have data residency requirements, you can operate. Let's say, for example, we have like U.S. stamps, Australia. I think we're working on Japan, and so I know we have like a Europe stamp as well. But this essentially meets those requirements. So it's like your own instance of GitHub in your region with your data. Whereas GitHub.com, generally, you're running where our servers
right.
Yeah,
that's awesome.
Yeah, it's actually that came out recently, so it's something that GitHub is expanding. Teams are building feature parity around it, right? Ensuring that the same features that you have on .com are available for GitHub with data residency.
Okay, I mean, it totally makes sense, right? You start thinking about like sovereign and stuff like that. It just makes sense. Yeah, awesome. So all right, we have another question. It says, what's your take on using GitOps Argo CD to deploy and manage GitHub Arc on OpenShift? Any expected challenges when dealing with Arc ephemeral resources?
Yeah, maybe.
Yeah.
Our official support goes as far as Helm. So we maintain Helm, and we try to make it so Argo CD or any other solution can basically work with our Helm charts. But the official thing that we maintain is the Helm chart. I have seen people definitely making it work. Now, would I recommend it if you are very well versed with Argo CD? Yeah, sure. So this is just basically a Helm chart. You just need to make sure that you understand what is going on, and you can use any tool on top of that as you want. That is my take, at least. Steve, do you have any?
When we added the annotations recently, right, to help with like other providers. So if you did want to use Argo or something different, then it would be easier with the annotations.
Yeah,
correct?
and we try to enable these features whenever we see them being blockers for other people, but we don't officially support it. We will definitely try to reproduce every bug that we see, and we try to figure out exactly what is going on, but it's not as heavily tested as Helm is, basically.
It's really using the tool for what the tool's built for, right? It's a CI tool, so you're building an image or you're building an application. So that's you're committing to your repo. You're letting the runner deploy to your cluster and build it in your cluster, and then there should be that handoff, right, where it goes from the CI tool to the CD tool, right, which would be Argo. The application gets updated, it gets patched with the new image version or whatever, and then starts the rollout to your clusters. So it's just using the tool where it's meant to be used. It's maybe not trying to extend it to do something that it maybe should be doing, but to deploy it should be just, hey, here's a Helm chart, here's some values, maybe here's an external secrets. That's really where I'm without looking at the chart, just trying to think of like, how would you loop in like a vault or the AWS key manager or whatever, right, for like a backend. So you know what I mean?
So we do have, yeah.
Sorry, Steve.
We actually no, you're fine. Because as soon as you said vault, many enterprises, organizations, especially in regulated environments, do not feel comfortable using the native etcd secrets within Actions Runner Controller. And so we provide vault support for Azure Key Vault right now. It's in our documentation if you need to configure it. We are looking into other key management things, but to be honest with you, Nikola and I, Arc is an open source project. We look at all the issues that are reported there. If people want like HashiCorp Vault, something from AWS, submit an issue, review it. Like if there's community engagement around it and the clear need, then it's something we'll look into, because a lot of the features and things that we build and capabilities are just based on, feedback that we're getting from the community.
That's awesome.
Yeah, and also just to add to that, just bringing this Azure Key Vault, we did a lot of heavy lifting to make sure that other key vaults can be included. So adding every next one to be added is going to be simpler to, because we already have the framework. How do we resolve these secrets either from the cluster itself or from the key vault?
Okay, awesome. Famous last words, man. Famous last words. I got one done. The next one's gonna be easy. 6 months later, we're working on it.
Yeah, we've got 4 new vaults coming in 2026.
Right.
We don't have plans for any right now, but if there are, we can add them easily.
So is that the, if I want to feature added, or if there's something that maybe I just want to see something, or I have a question, is that the right way to go? Just go to the Arc repo and put in an issue and get some traction that way? Are you guys on Slack or anything?
Yeah. No, we just use the repo for
That's
communications with the community. Now, if you are like in an enterprise with GitHub, let's say you have like a premium plus support subscription, right? You go through support, that will come through our team, right? That will come to us in a different way. So like we like the way I kind of see it is if there's like enhancements. I mean, we even have members of the community who will submit pull requests and things, right? And Nikola and I will review those and say, oh, this is actually good to go. Only a couple changes, and we can include this in the next release.
Okay. So are y'all both the maintainers for this?
Okay. Nikola's the maintainer. I'm the PM.
Okay, cool. Yeah, I didn't mean to put you on the. You're like, no, hell no.
No. You're fine. You're fine. I don't think Nikola wants me mucking around in the code base. But I will respond. I will respond to issues and
Gotcha.
other things.
Gotcha. And Mr. Dog 1515 said, "What about integrations with secret management tools like HashiCorp Vault, Delinea, etc.? Are they on the roadmap?" And I'll recap what you just said, and then you just correct me if I'm wrong.
Yeah.
But the idea is they have Azure Key Vault as a built-in config now that works, that's supported. Anything else you would just have to put in an issue. Like the hooks are there, there's no support for it out of the box right now.
And so that's something that you really need. Please submit an issue as soon as possible. We're working on the 14.0 release right now, and we expect to ship that before the end of March. So now will be a good time.
That's awesome. So are you guys going to KubeCon? Are you going to be at Summit, KubeCon? Are y'all doing any of that?
I'm not going
this year. I do want to go. I was in Chicago one year when KubeCon was going on, but I had something else to take care of. But it's definitely something that in the coming years we want to attend.
Okay, gotcha. Yeah, it was cold that year, by the way. I walked around. I got a hotel like 2 miles away. I'm like, it's only 2 miles, to be fine. I froze. I'm like, this is a terrible walk. Let's see. So what else you guys got? What's on the roadmap that's big that you're excited about?
I'd
that
say
you can talk about.
Yeah, 2 things. One is multi-label support. So when GitHub took over the original SummerWinds project, and we moved to creating our own supported version of Actions Runner Controller, we went away with multi-label support because we wanted very discrete ways for calling out compute and in opinionated ways of scaling. So when I go back to mentioning, we recommend having multiple scale sets created with different types of compute for different jobs. That's kind of where that approach comes from. Well, the community was not happy about this at all. Many of our customers are not happy that we dropped multi-label support. And so as part of what we're working on this year with the 14.0 release, we're bringing multi-label support back for Actions Runner Controller. The other thing that we are doing that I think is very exciting in this space is in addition to Actions Runner Controller for self-hosting your Actions jobs, you can also, so Arc uses something called scale sets. Scale sets are the things that it runs on, but scale set is also the name of a service that is used for scaling, right? It's the communication with GitHub. We are, if you will, extracting some of the scaling components that are directly tied to Arc today and creating a new open source project called the GitHub Scale Set client, which essentially allows you to self-host on anything, right? So you can run the Scale Set client on OpenShift, you can run virtual machines, you can run containers. We are essentially Arc required organizations to have Kubernetes expertise in order to auto-scale their runners, right? We just heard, hey, I need to run Windows. I have Mac builds. Like, I want to self-host. I don't want to go through another platform. And so the Scale Set client is something that we are going to ship this quarter as well. And that will come with multi-label support as well.
Hell yeah, man.
Yeah.
I'm just thinking like from a nerd, right? Like,
yeah.
I have a requirement. You guys I love the product. I love GitHub. These runners things are cool, but I've got like this other non-Kubernetes environment, and I would love to use this thing, but I can't. And you guys are like, boom, done. We're shipping it. There you go. That's what all this is about, right? To me, this is what open source is. It's like, hey, this thing would be awesome. You could either code it up, or obviously I'd just go to Nikola and be like, hey, dude, I need to be able to run this in Windows. It'd be awesome. I love it. Yeah, that's really great.
In fact, the way that we look at it now is that Actions Runner Controller is a reference implementation of the Scale Set API. And the Scale Set client is just another reference implementation of the Scale Set API. It's an opinionated one. However, it is more of I want to say like a build your own autoscaler. So it's meant to be taken and then customized and built on top of. Like, we're not hoping that, we have like a Docker Scale Set example built into the repo that people will be able to use on day one. But the goal is, we don't want GitHub to block you when you're self-hosting your own application, your own CI. And so here are some tools for you to use. Go take and build what you need, fork it. That's our hope. It's just to put more power into the developer's hands.
Here's how you start, right? Here's your first layer of Legos. There you go. You do the rest.
Yeah, you can think about it as just extracting the listener and not having a controller. So basically, you swap the controller with anything else. You can spin up VMs. You can do anything you'd like, and that's basically it. So it basically outgrows the Kubernetes itself.
Yeah, but you have to be able to adapt at this point, right? Like, there's been this. You guys are. I don't know how to do this, but like, we went from like physical machines to VMs to containers, back to VMs to Kubernetes to all. You know what I mean? But like, we're at this point now where it's like, okay, well, I need to be able to do it all. It's not like we've got these like periods in time like we did before, where it was like bare metal, virtual machine, containers. You know what I mean? Like, now it's like, okay, actually, I need cloud, I need data center, I need to work on my laptop. You know what I mean? Like, we have to be able to adapt to all these different things. And it sounds like you were presented with a problem and you were able to solve the problem. And that to me, I get excited about stuff like that, because it's actually listening and trying to make it better. You know what I mean? So like, it's fun. CMAX team does it a lot, like Argo and the stuff we do with OpenShift GitOps and pipelines. Like, it's freaking awesome, and I love it. So keep it up.
Yeah.
And I'm particularly, like Steve and Nikola, excited about that bit, because we do have some customers that run Windows applications in a VM on OpenShift. And what you described essentially allows them to be able to use those Windows-based VMs to hook it up to self-hosted runners, and which is not possible for them today. So it's a really exciting part of what's coming, actually.
Yeah, that was a big ask. We were like, how are you going to, it was like provide, Windows for Arc. And we were like, oh, that's going to be hard. We need to think through this. And that's kind of how it sort of started, right? Like, these just compounding requirements. I mean, for the most part, Arc and Kubernetes, for at least the customers that we engage with, covers, close to 70-80% of their build estate. But then there's the Windows builds. There's some might have a Mac app as well, right? And they want to keep everything in the same pipelines.
Yeah, no, it's awesome. I love it. We got one more question. It says, can you recommend the best book or any document page for learning Kubernetes? So from an OpenShift perspective, go to learn.openshift.com, or maybe it's learn.redhat.com. It's definitely try.openshift.com. That's one. And then there's learn.openshift.com, which has a bunch of resources. It basically redirects you to developers.redhat.com. If you do not have a developer subscription, you 1000% need one. It's free. You get 16 nodes of OpenShift for free a year. And you can, the stuff that Nikola was doing with CRC, that's one thing that you could do. You could actually throw in like if you wanted to build a snow cluster, single node OpenShift, you could do that. If you wanted to have a 3-node compact or like a 3 and 3 control plane, whatever you wanted to do, you have a free subscription that allows you to do this and gives you access to the Red Hat software. And or if you wanted to stand up a VM or an EC2 or something like that, and you wanted to play with Ansible or maybe put Podman on it and do some crazy stuff like that, also there and also free. But there's different demos that you can do. There's different guides that you can go through to learn like about this the technology. So it's definitely worth just checking out. Try.openshift.com, learn.redhat.com. On the Kubernetes side, the thing that I always used was the Linux Foundation CKA. Like I learned by having a goal, and so like if I have I want to get my CCAT or my CKA, then that's my goal, and then I just work to get to that target. Kubernetes the Hard Way by Kelsey Hightower is pretty much like the Bible of all Kubernetes these things. You know, like if you want to learn the ins and outs of everything, that is you're gonna pull your hair out doing it, but it's amazing. You'll learn a lot. So I don't know. Do you guys have any resources that you guys use?
Yeah, I'm going to give a shout out to an engineer on the Actions team. His name is Bassem Dihaji. He runs, he has a bunch of Udacity courses. He has one on Actions Runner Controller that he published maybe 2 years ago. It is still relevant, right? We have some minor changes there, but it is based on GitHub's version of Arc. I remember when my director first said, "Hey, Steve, you're going to take over Actions Runner Controller." And I was like, wait, okay. I haven't touched self-hosted since I started at GitHub, but let me learn it. And then I started working with Nikola and Bassem, who's not on the project anymore. But he's like, oh, I have this course, and I took it, and I was like, oh, I feel like I'm an Arc expert in 3 weeks. Like it, essentially. We did have the bonus of me being able to like Slack him questions and stuff along the way. But even without that, right, I found that, like you were saying, Johnny, like having a goal, like something you're working towards, some practical things, helped me like on the Arc side, right? It was my first time setting up a Kubernetes cluster, walks through all of that. And so that was kind of like an intro, and then getting into the deeper topics and then the more, platform and industry specific things over the years.
Nice.
Yeah.
Nice.
And what I would definitely like to mention is there is a KubeBuilder book. So once you get familiar with Kubernetes itself, there is a book how to write your own controller. So they would go over creating a cron job controller. As far as I remember, that was great experience because you get to see what the code looks like. And our Actions Runner controller relies on the same library as like most of the KubeBuilder is doing, which is basically controller runtime. And
Nice.
from there, you can basically build your own controller and understand what is going on, how do controller react, and how do you design them if you need that.
That's awesome.
And Bassem has a video on his YouTube. It's 2.5 hours, and that one is just amazing walkthrough for the Actions Runner controller as well. So.
How do you spell it? I'll put you on the spot. I gotcha.
Yeah.
I'm just this is for research purposes, educational, academic.
Let me find it.
I can send you a link.
Yeah, if you have one. And what I'll do is I'll update the show notes with all the links that we've shared in the stream today. But yeah, it's always good. I think when you're learning, especially like don't turn your nose up at if somebody's like, oh, you should try this. But I don't learn like that. But just give it a shot, because like you might learn a ton. Like me personally, if I have a goal, then it's so much easier for me to consume things, because then I get fixated on the goal, and then just getting there is, like however I learn to get there is just how I learn to get there. Like, but I like reading, I can listen. And then obviously I'm in the fortunate position to be, a host of a live stream where I could just ask a bunch of questions and be stupid and just, have a great time. So I learn all kinds of ways. Oh,
Yep, and
awesome.
we sent the link in the chat.
Yeah.
That's the same one that we both sent.
Yeah. I noticed after I pressed enter.
Yeah, Raul, you can't share links coming from YouTube. YouTube strips them out. So like even if you're sharing it, it probably looks great on your side, but like, yeah, they strip it out so it doesn't come through. So I think if you wanted to, you could do it on Twitch. All right. Well, we are over time here. But do you guys have any last things that you want to talk about before we go? Steve was like, I'm done. Oh, and now I can't get back. Here we go.
My internet dropped. That was weird.
Yeah, Steve was like, up
I'm still here.
later.
Yeah, I was about to say goodbye, and then it dropped me. Kicked me out right away.
Yeah,
Awesome. It was a ton of fun today.
Good. I'm glad we were able to work it out. And yeah, I think I'm really excited about the runners. I think it's awesome. I use GitHub Actions every day. But to now have the ability to have the runners on our cluster, I definitely want to give it a shot and just kind of see how, just get like what the experience is like and stuff like that, because I feel like we want to. It feels like it makes sense in art, like what my team would be using it for. You know what I mean? So like it's exciting. So.
And then one more shout out. Simak and I are also working on some other things, so keep an eye on the GitHub public roadmap.
Yeah.
Oh, nice.
Yeah.
Nice. Awesome. Steve Mac, do you have anything you want to put out?
I just wanted to give a short shout out also to Chris Keller and Chris Peters, the two solution architects Red Hat that wrote that blog that Nikola was showing. That was very instrumental in the work that we have done. And yeah, exciting progress. I'm looking forward to the rest of Steve and Nikola. We have a lot planned. This is a very strong work going forward. We've on both sides, both GitHub and us, we hear a lot of feedback from customers about this. So we really appreciate both the feedback and the work that we are doing on both sides to accommodate the feedback we're getting.
Yeah, awesome. And if you guys have an update and you want to come back on the stream, let me know. We'd love to have you. I think like this to me, being able to show it and use it and actually put it in a perspective so people can understand where it's useful, I think it's really good. So yeah, if you want to come back, let me know. I'd love to have you.
Sounds good.
We'll do.
Awesome. All right, cool. So yeah, so again, next week we're not going to be streaming, and then once we get back, we've got a bunch of topics coming up. So it'll be really busy week after next, like going into February through hopefully up into Summit or KubeCon EU at the end of March. Anyways, we got a lot going on. It's gonna be awesome. So until then, have a great week and have a great weekend. Thanks again, guys.
Take care.
See you, everyone.